Hello everyone, welcome back to my channel. In the previous class, we have discussed about the proofs of derivative of hyperbolic functions. In this class, we will learn how to prove the inverse hyperbolic functions formulas. So the first formula is given sin hyperbolic inverse x, which is equals to ln x plus root over x square plus 1. So this is the formula. By the help of sin hyperbolic inverse x, we will prove the right hand side value. That means we will have to get the value of right hand side, that is ln x plus root over x square plus 1. So consider this x as, that means the sin hyperbolic inverse x as y. So when we change this one, that means we can write this one as y is equals to x upon sin hyperbolic. Then this sin hyperbolic will get multiplied to the other side, then we get x is equals to sin hyperbolic y. So we know the formula of sin hyperbolic x, which is e to the power of x minus e to the power of minus x upon 2. Here the variable is y. So I have written e to the power of y minus e to the power of minus y upon 2. Then just multiply this value to the other side. Then we get 2x is equals to e to the power of y minus e to the power of minus y. Then to get this value, I just multiplied here the e to the power of y value. Now multiply e to the power of y in both sides. So when we multiply e to the power of y in both sides, then we get the equation as 2x e to the power of y, which is equals to e to the power of y into e to the power of y minus e to the power of minus y into e to the power of y. If you see this part, e to the power of minus y into e to the power of y. So when the bases are same, we just add the powers. So e to the power of minus y plus y, then we get e to the power of 0, which is equals to 1. Anything to the power of 0, we get the value 1. So I have written the value as 1. Then just alter the values. That means we have to write it as an algebraic expression. So for algebraic expression, I have taken as e to the power of y whole square. So this value will change to the other side. Then we can write it as minus 2x e to the power of y minus 1 is equals to 0. So now consider e to the power of y as u. So when we consider the power e to the power of y value as u, we can write that equation as, so u is equals to e to the power of y. That means we have to replace u in place of e to the power of y. Then we get u square minus 2ux minus 1 is equals to 0. Then after, what we have to do is, after this step, we use the quadratic formula. That means x is equals to minus b plus or minus root over minus b square minus 4ac minus 4ac upon 2. By using this one, we can get the value. So next we will substitute the values. Consider this one as, this is our a value and b value is minus 2x and the c value will be minus 1. Then I can substitute the values as u is equals to, so b value is nothing but minus 2x. So 2x plus or minus root over, here the b square value, that means 4x square minus 4 ac, means a value is 1 and c value is minus 1. On multiplying, we get plus 4 upon 2a. A value is 1, so which will be 2. On taking common, that means we will take the 2 value as common, then we get the value as x plus or minus root over x square plus 1, because root 4 value is nothing but 2. So when we take the common 2, we only get x square plus 1. So this is what we got here. Then in the next step, I have taken the positive value only because e to the power of y. Here I am writing the reason for taking the positive term since e to the power of y is positive. So e to the power of y is a positive value. So I have considered u is equals to x plus root over x square plus 1. Then as we have substituted, if you see here, we have substituted the value of u as e to the power of y. Again I will change this u to e to the power of y. Then e to the power of y is equals to x plus root over x square plus 1. Then from here, again there is a step to cut this value. We will multiply the ln to the both sides. Then we can get it as ln e to the power of y is equals to ln x plus root over x square plus 1. So if you see here, these two values will cancel out. That means ln and exponentials value. Then I will write it as y is equals to ln x plus root over x square plus 1. So x value, which is nothing but we have taken the value of y is nothing but the value of y is sine hyperbolic inverse x. So y, here I have written the y value as sine hyperbolic inverse x, which is equals to ln x plus root over x square plus 1. So this is the first formula of inverse hyperbolic functions formula. And then the second one is given cos hyperbolic inverse x, which is equals to ln x plus root over x square minus 1. The same steps we have to follow here. As I have taken the cos hyperbolic inverse x value as y, again by changing this value, that means I can write it as y is equals to x upon cos hyperbolic. On multiplying this value to the other side, I can write this one as x is equals to cos hyperbolic y. And the formula of cos hyperbolic x is e to the power of x plus e to the power of minus x upon 2. So here the variable is y. So I have written as e to the power of y plus e to the power of minus y upon 2. Now multiply this value to the other side and we get 2x is equals to e to the power of y plus e to the power of minus y. And similarly we have to do the step which we have done in the previous formula. We have to multiply e to the power of y both sides. That means we have to multiply this e to the power of y in both sides. Then we get 2x e to the power of y, which is equals to, as I have solved in the previous formula, if you see here, e to the power of y into e to the power of y, which is nothing but e to the power of y into e to the power of y, which is equals to e to the power y plus y. So which is equals to e to the power of 2y. In the same way, I have written here e to the power of y square plus 1. Then we have to change this equation to algebraic expression. So I have changed to algebraic expression. Then I can substitute the value of e to the power of y as u. So after substituting the value of e to the power of y as u, we get this equation. Then for this equation, we have to apply the quadratic equation. So after applying the quadratic equation, we get this value. So this is the value which we got. If you see here, this is our a value. A value is nothing but 1 and b is our minus 2x and then c is 1. So the formula will be u is equals to minus b plus or minus root over b square minus 4ac upon 2a. So this is what we have the formula. Then on substituting, we will get an equation that is, we can write it as the value of after substituting the values, we get u is equals to 2x. Similarly, which we have done in the previous question, the same steps we have to follow here. 2x plus or minus root over 4x square minus 4 upon 2. By taking 2 as common, then we get u is equals to x plus or minus root over x square minus 1. Here also the same statement which we will use. We will take only the positive term, since e to the power of x, e to the power of y is a common positive value. And then here the u value is nothing but e to the power of y. So e to the power of y is equals to x plus or minus root over x square minus 1. So for this I can write it as e to the power of y is equals to x plus root over x square minus 1, because e to the power of y is positive. So this is the reason. Then to cut the exponential value, we have to multiply ln both sides. On multiplying ln both sides, we can cancel out the value. Then we get y is equals to ln x plus root over x square minus 1. The value of y is nothing but cos hyperbolic inverse x, which is equals to ln x plus root over x square minus 1. So this is the formula of cos hyperbolic inverse. So this is our cos hyperbolic inverse x formula. And the previous one, the formula was sin hyperbolic inverse x, which is equals to ln x plus root over x square plus 1. Then the third formula is about tan inverse. So the tan inverse formula is given 1 by 2 ln into 1 plus x upon 1 minus x. So the same steps we have to follow. We have to take the tan hyperbolic inverse as y, then the x value will change to tan hyperbolic y, and the tan value will be e to the power of y minus e to the power of minus y upon e to the power of y plus e to the power of minus y. As we have discussed in the first part of our video, the formulas of hyperbolic functions. From that, I have used the tan hyperbolic y formula. Then after substituting, you can multiply this value to the other side, and we can write this statement as this. Then on multiplying, we get e to the power of y into x, then plus e to the power of minus y into x will be equal to e to the power of y minus e to the power of minus y. Then if you see here, there are two terms of which we have the power as y, and again these are the two terms where we have the minus y as the power value. Then the next step will be written as e to the power of y x. So here on changing, this one will be minus e to the power of y, which is equals to minus e to the power of minus y minus e to the power of minus y into x. If I take e to the power of y as common, e to the power of y into x minus y. Then here also, again I am taking the e to the power of minus y as common. Then the value will be minus 1 and minus x. Then we can see here in the next step, we can write it as, to cancel the x minus 1 value, we just divide the value of x minus 1 and we have to multiply the x minus 1 value. So I can write it here. Wait for a while. So I can write it here, multiply e to the power of y and multiply e to the power of y and divide x minus y. So in this step we get the value as e to the power of y will be multiplied, so we get e to the power of 2y, because e to the power of y into e to the power of y will be 2y. Then here the x minus 1 will be cancelled out, which is equals to, again here e to the power of y multiply of e to the power of y will be 1, because e to the power of 0 will be 1. Again here we get the value as minus 1. So here it is given that minus 1 minus x upon x minus 1. So in the next step, I can write this one as e to the power of 2y is equals to minus of 1 plus x, then taking the minus as common, 1 minus x. So these two terms will cancel out. Again, we got the value here. That means 2y is equals to ln 1 plus x upon 1 minus x, because we will take ln both sides. So on taking ln both sides, the next step will be written as taking ln both sides. So on taking ln, the next step will be e to the power of ln e to the power of 2y, which is equals to ln 1 plus x upon 1 minus x. So here the ln and exponential value will get cancelled out, and the remaining value will be 2y is equals to ln 1 plus x upon 1 minus x. So when this 2 will come to the other side, it will get divided. So y is equals to half ln 1 plus x upon 1 minus x. The value of y is nothing but tan hyperbolic inverse of y, which is equals to 1 by 2 ln 1 plus x upon 1 minus x. So this is one of the formula of inverse hyperbolic function. Then the fourth one is about coth hyperbolic inverse of x, and we have to prove that the value of coth hyperbolic inverse of x is equals to half ln x plus 1 by x minus 1. The same step we will take here. That means coth hyperbolic inverse x will be equal to y, and the x value will be coth hyperbolic y. We know the formula of coth hyperbolic x. So here the variable is in the form of y. So I have taken coth hyperbolic y formula. Again, multiply this value to the other side and we get e to the power. So this will be written as, let me write this one as, so this equation will be written as e to the power of y into x minus e to the power of minus y into x is equals to e to the power of y plus e to the power of minus y. Similarly, as we have done for the tan, we also use the same steps to solve this one. So this will be, the next step will be e to the power of y x minus e to the power of y will be equal to e to the power of minus y of x plus e to the power of minus y. Then on taking common the e to the power of y, we get e to the power of y x minus 1 is equals to e to the power of minus y. Here we are taking the common term of e to the power of minus y. Then x plus 1. If you see here, the next step will be written as, so here the two values are, so e to the power of y. If you see this one, I am changing this value to the other side, so I can write this one as x plus 1 upon x minus 1, and here we have the e to the power of minus y value. So on multiplying e to the power of y to the both side, so multiply e to the power of y. So on multiplying we get e to the power of 2y is equals to, here we get e to the power of y into e to the power of y will be equal to 1. So which is equals to x plus 1 upon x minus 1. We got this value. After that, to cancel out the exponential value, we will multiply the ln e to the power of 2y is equals to ln x plus 1 upon x minus 1. So just cancel out the value. We get 2y is equals to ln x plus 1 upon x minus 1. So we know the y value, which is nothing but coth hyperbolic inverse x, and this value will be changed to the other side. Here it is in the multiplied form. When this comes to the other side, we can write it as coth hyperbolic inverse x is equals to 1 by 2 ln x plus 1 upon x minus 1. So the next formula is sec hyperbolic inverse x is equals to ln 1 plus root over 1 minus x square upon x. So let me highlight this one. So this is what we got the value. Now we will do the fifth formula. So the next formula is sec hyperbolic inverse x is equals to ln of 1 plus root over 1 minus x square upon x. The same way we will consider the sec hyperbolic inverse x as y. Then the x value will be sec hyperbolic y. And we know the formula of sec hyperbolic x. Since here the variable is in the y form, so I have taken the formula 2 upon e to the power of y plus e to the power of minus y. So to change this one, we can reciprocate this value. So on reciprocating this value, we get 1 upon x is equals to e to the power of x plus e to the power of minus y upon 2. Now multiply this value to the other side and we get 2 upon x is equals to e to the power of y plus e to the power of minus y. Now on multiplying, so here we will multiply e to the power of y both sides. We get e to the power of y 2 upon x is equals to e to the power of y plus e to the power of minus y into e to the power of y. Here what we have done is, in this step, I just multiplied e to the power of y into e to the power of y will be equal to e to the power of 2y. And similarly, e to the power of y into e to the power of minus y will be equal to e to the power of y minus y is equals to e to the power of 0, which is 1. So we got this one. Then the next step will be, we have to write it as in the form of algebraic expression. After writing the algebraic expression, we have to follow the quadratic formula, which is u is equals to, or x is equals to, minus b plus or minus root over b square minus 4ac upon 2a. So here the value of, and we have to substitute the values. Then we get here the value of a is 1 and b will be minus 2 upon x and c is 1. On substituting those values in this quadratic form, we get the value as u is equals to 1 plus or minus root over 1 minus x square upon x. We know the form as we have considered here e to the power of y as u. So here again we can change this value to e to the power of y, which is equals to 1 plus or minus root over 1 minus x square upon x. As we know the reason, because we have to take the positive value since e to the power of y is positive. Then y is equals to ln 1 plus root over 1 minus x square upon x, and the y value is nothing but sec hyperbolic inverse x is equals to ln 1 plus root over 1 minus x square upon x. So this is the sec hyperbolic inverse x formula. Then we will go for the next formula, that is cosec hyperbolic inverse x will be equal to ln 1 upon x plus root over 1 plus x square by mod of x. So the same steps we have to follow here by considering the cosec hyperbolic inverse x value as y, and again then the x value will change to cosec hyperbolic y, and the cosec hyperbolic function is 2 upon e to the power of y minus e to the power of minus y, and by reciprocating this value I can write the step as 1 upon x is equals to e to the power of y minus e to the power of minus y upon 2. Then just multiply this value to the other side, then we can write it as 2 upon x is equals to e to the power of y minus e to the power of minus y. Again in this step also we have to again multiply e to the power of y in the both case, that means in the both sides. Then we get 2 by x e to the power of y is equals to e to the power of 2y minus 1. So as we have done in the previous question, the same step has to be followed out here. Then we get this equation will be written as e to the power of 2y minus 2 upon x e to the power of y minus 1 is equals to 0, and e to the power of y will be replaced as u. So we can write this one as u square minus 2 upon x u minus 1 is equals to 0. So this is our algebraic expression. Then we can follow the quadratic formula. So on following the quadratic formula, we get the value somewhat this one, that means u is equals to 1 plus or minus root over 1 plus x square upon x. So we know u is nothing but e to the power of y. So on cancel outing this exponential, we have to multiply ln both sides. That means ln e to the power of y is equals to ln of 1 plus root of plus or minus. So here we will take the positive one only, since y to the power of y is a positive value. So 1 plus root over 1 plus x square upon x. So then the ln values will get cancelled out, and the remaining will be y is equals to 1 plus root over 1 plus x square upon x mod. So the cosec hyperbolic inverse x value is equals to ln 1 upon x plus, so here mod is nothing but if we have any of the negative terms, consider x is, suppose minus x is given, if we apply mod, then the value will be positive only. So 1 upon x plus root over 1 plus x square by x mod. So this is the cosec hyperbolic inverse formula. So these are the inverse functions. So you will get as a long questions for your exams also. Now we have the derivative of inverse hyperbolic functions. So these are the very short form of formulas we can derive out. So the first one is given as we have done for the inverse hyperbolic functions. The previous one, for the derivation also we have to consider the sine hyperbolic inverse x as y. Then the x value will be changed to sine hyperbolic y. Here I have done the derivative of this value. That means derivative of this function. So d by dx of x is equals to derivative of sine hyperbolic y. So the derivative of x will be 1, and the derivative of cos hyperbolic y will be cos hyperbolic y dy by dx. Okay, then on changing this cos hyperbolic y to the other side, we get dy by dx is equals to 1 upon cos hyperbolic x. We have discussed some of the formulas like cos hyperbolic square y, because here it is given in the form of y, so I have taken the y. Cos hyperbolic square y minus sine hyperbolic square y will be equal to 1. Here it is given in the cos form. So as I have told you that this is in the form of cos hyperbolic y, so I have to follow this formula. Then we can change this one to cos hyperbolic y. Cos hyperbolic square y is equals to 1 plus sine hyperbolic square y. When we take this square and we can write here the root, then this changes to cos hyperbolic y is equals to root over 1 plus sine hyperbolic square y. So we got the cos hyperbolic y formula. So this is the formula which we got for cos hyperbolic y, and this value has to be substituted in the next step. So if you see here, sine hyperbolic y we have taken as sine hyperbolic y formula, that means the function we have taken as x. So here I have written 1 upon 1 plus x square root over. Then we got the value of sine hyperbolic inverse x, because here the derivative of y is nothing but our sine hyperbolic inverse x. So we got the 1 upon root over 1 plus x square. So this is the formula which we have got here. So this is the formula of sine derivative of sine hyperbolic inverse x. Now the next formula is given, that derivative of cos hyperbolic inverse, which is equals to 1 upon root over 1 plus x square. The same steps has to be followed here. Only the change is, as we have written cos hyperbolic square y minus sine hyperbolic square y is equals to 1. Then here we got, if you see here, we have done the derivative with respect to x. So with respect to x we have done, so we got the, I have to write it here. So here we have done the derivative with respect to x. So the derivative of x will be 1. The derivative of cos hyperbolic y will be sine hyperbolic y dy by dx. After that, if you see here, if I change this value to the other side, then I can write dy by dx is equals to 1 upon sine hyperbolic y. Since here it is in the form of sine hyperbolic y, I can change this formula to in the form of sine hyperbolic y, that is cos hyperbolic square y will be equal minus 1 is equals to sine hyperbolic square y. Then on taking on taking root to the both sides, that means squaring both sides, we can get cos hyperbolic square y minus 1 root over is equals to sine hyperbolic y. So we got the sine hyperbolic y formula and I have substituted here, and the cos hyperbolic square y, that means cos hyperbolic y is equals to x. So we got the dy by dx is equals to 1 upon root over x square minus 1. Then we got, as we know, the y is nothing but our cos hyperbolic inverse of x. So we got the derivative of cos hyperbolic inverse x formula. Then the third formula is given, derivative of tan hyperbolic inverse x is equals to 1 upon 1 minus x square. So we will take the tan hyperbolic inverse x as y, and we get the y value as tan hyperbolic y. Here also we have to follow the step called differentiating with respect to x. That means this equation has to be differentiated with respect to x. So the derivative of x will be 1, and the derivative of tan hyperbolic y will be sec hyperbolic square y dy by dx. So here also we have to follow the formula, as we have sec hyperbolic square y is equals to 1 minus tan hyperbolic square y. So this formula I have used in this step and I have substituted the value. If you see here, tan hyperbolic y is equals to x. So tan hyperbolic square y will be equal to minus x square. On taking this value to the other side, we can write it as dy by dx is equals to 1 upon 1 minus x square. So we got the value, and the y value is nothing but tan hyperbolic inverse. So this is the formula of derivative of tan hyperbolic inverse x. Then the fourth formula is about cot hyperbolic inverse x. That means we have to do the derivative for this inverse of cot hyperbolic x. So considering this one as y, that means cot hyperbolic inverse as x as y, and then we get the x value as cot hyperbolic y. Again differentiate with respect to x. On differentiating this value with respect to x, we get this x as 1, and the derivative of cot hyperbolic y will be minus cosec hyperbolic square y dy by dx. Then again we have to follow the formula. We have a formula called cosec hyperbolic square y is equals to cot hyperbolic square y minus 1. So since this is in the form of, so here it is in the form of minus cosec hyperbolic square y, we can change it as, that means we can write it as, because here the minus is present, so minus cosec cot hyperbolic square minus y. Here I have to write the next step as 1 is equals to minus, so minus cot hyperbolic square y minus 1 dy by dx. So here the cot hyperbolic square y is nothing but x value. So minus of x square minus 1 dy by dx. So on multiplying the negative value, I get the value as 1 is equals to minus x square plus 1 dy by dx. Now change this one as I can write it as 1 is equals to dy by dx. So this value I have multiplied to the other side. So 1 minus x square. So if you see here, this is what we got, the formula of cot hyperbolic inverse, and here the y value is nothing but cot hyperbolic inverse. So this is the formula of cot hyperbolic inverse, and then it is given sec hyperbolic inverse x derivative is minus 1 upon x root over 1 minus x square. By taking sec hyperbolic inverse x as y, then we get x value as sec hyperbolic y. So here also I have done the derivative with respect to x. So derivative with respect to x. On derivating, I got the derivative of x as 1 and the derivative of sec hyperbolic x or sec hyperbolic y, we get the derivative as minus sec hyperbolic y into tan hyperbolic y dy by dx. Now just take this value to the other side, we get minus 1 upon sec hyperbolic y into tan hyperbolic y, which is equals to dy by dx. Then as we know the formula, we can check it out here. Tan hyperbolic square y is equals to 1 minus sec hyperbolic square y. So by this one, I can write it as tan hyperbolic y is equals to 1 minus sec hyperbolic square y root over. In the same way as I have written, if you see here, x is nothing but we have taken the sec hyperbolic y. So 1 minus x square, that means our sec hyperbolic y value, and then we get y value is nothing but sec hyperbolic inverse x, which is equals to 1 minus root over x into root over 1 minus x square. So this is the formula of derivative of sec hyperbolic inverse x formula. Then the last one is about the derivative of cosec hyperbolic inverse x. So here it is given, which is equals to minus 1 root over mod of x root over, so minus 1 upon mod of x root over 1 plus x square. Now we will take the cosec hyperbolic inverse as x, and then we can change to then we can change this one to x is equals to cosec hyperbolic y. So after taking the cosec hyperbolic y, then we have to do the derivative for this one. So differentiate with respect to x. So after differentiating with respect to x, we get the derivative of x will be 1 and the derivative of cosec hyperbolic y will be equal to minus cosec hyperbolic y into coth hyperbolic y dy by dx. Now change this value to the, that means on shifting this value to the other side, we get minus 1 upon cosec hyperbolic y into coth hyperbolic y is equals to dy by dx. Now in this step, again we have a formula called coth hyperbolic square y, which is equals to, or we can write it as, which is the first formula, coth hyperbolic square y minus cosec hyperbolic square y, which is equals to 1. Then coth hyperbolic y will be equal to, I can write it as 1 plus cosec hyperbolic square y. So here the cosec hyperbolic y will be our x value, then mod of x, which is equals to, the y value is nothing but cosec hyperbolic inverse of x. So which is equals to minus 1 upon mod of x root over 1 plus x square. So this is our derivative of cosec hyperbolic inverse x formula. And then we will also we have some of the formulas of special formulas. So those formulas we will discuss in the next class. That's it for today. Thank you.